Welcome back to Surface Various, your trusted channel for expert insights on surface preparation and industrial cleaning technologies. In today's episode, we go behind the scenes into the fascinating world of dry ice, the same carbon dioxide in solid form that powers high performance cleaning systems like cold jet and ice jet. We will uncover how dry ice is manufactured from liquid carbon dioxide, how it is processed into pellets and best practice for storage, and how it is safely transported and distributed to industries across the UAE and beyond. Whether you are a cleaning contractor, facilities engineer, or industrial manager, understanding dry ice logistics will help you to make smarter, cost-effective decisions for your operations. Dry ice was accidentally discovered by the French chemist Adrien Jean Pierre Tillorier in the year 1835. Tillorier found that when liquid carbon dioxide was released from a pressurized container, part of the gas evaporated quickly, leaving behind a solid white residue. At that time, dry ice was mainly used for refrigeration, especially in the food industry, and for transporting perishable products. During World War II, dry ice was used to preserve blood, medicines, and food on the battlefronts. Unlike regular ice, which melts into liquid, dry ice transitions directly from solid to gas in a process called sublimation. Because of this, it leaves no residue after evaporation. Its extremely low temperature makes it an ideal resource for refrigeration, fog effects, and various industrial applications. Its primary function is to preserve items in places without refrigerators. For example, during a heart transplant, dry ice is needed to keep the organ cold during transport. It is also used to transport vaccines. Any type of biological material, as dry ice is ideal for maintaining low temperatures. When submerged in hot water, carbon dioxide is quickly released, creating thick fog, making it perfect for special effects. Dry ice is used from pure carbon dioxide extracted and processed from various industrial sources. Carbon dioxide is generated as a byproduct of sugar, fermentation, and alcohol production at breweries and distilleries. This gas is captured, purified, and stored during ammonia production. In fertilizer manufacturing, carbon dioxide is generated as a byproduct and captured before being released into the atmosphere during the transformation of hydrocarbons into fuels and chemicals. Carbon dioxide can also be recovered from fossil fuel combustion in power plants. The carbon dioxide obtained from these sources contain impurities that must be removed to ensure safe use in dry ice production. Solid particles and coarse impurities are filtered out using mechanical filters. The gas then passes through washing towers where another chemical compounds are removed. The carbon dioxide is compressed at high pressure around 15 bar to facilitate handling and storage. This pressure is equivalent to being 150 meters below sea level. The carbon dioxide is then cooled to approximately minus 20 to minus 30 degrees, turning it to a cryogen liquid. In this stage, it is easier to transport and store in tanks. Once purified, the carbon dioxide is stored in cryogenic tanks designed to withstand high pressure and low temperatures. These tanks are made of stainless steel to prevent corrosion, have safety valves to overpressure, and kept below freezing temperatures to avoid carbon dioxide evaporation. This product can be transported to customers in tankers, trucks, or used directly in dry ice production. Inside the plant, liquid carbon dioxide is transported from storage tanks to the production facility through pipelines, specialized dry ice manufacturing machines. Since high concentration of carbon dioxide can be suffocating, facilities are equipped with ventilation and monitoring systems to control carbon dioxide levels. Additionally, employees wear safety goggles and personal gas detectors as protective measures when carbon dioxide is injected into the production machine. The pressure is reduced to about 5 bar, allowing carbon dioxide snow to form. This decompression occurs rapidly, causing the temperature to drop drastically. The transformation of liquid carbon dioxide into carbon dioxide snow happens through a rapid expansion, which is achieved by reducing pressure in a controlled manner. As it expands quickly, carbon dioxide undergoes instant cooling by absorbing energy from the environment. This causes part of the carbon dioxide to transition from liquid to solid, forming tiny snow particles. Another portion of the carbon dioxide turns into gas and is released through a ventilation system. The carbon dioxide snow is collected in a chamber inside the dry ice production machine, accumulating in the form of a fine, loose powder similar to real snow.
However, this carbon dioxide is not compact and must be processed into blocks or pellets. In the next step, to turn carbon dioxide snow into solid dry ice, a hydraulic press system applies high pressure to the material. Large amount of carbon dioxide snow are introduced into a rectangular mold where hydraulic piston applies up to 300 bar pressure. Under this pressure, the snow particles are bound together, forming a compact solid block dry ice. The resulting dry ice has a temperature of minus 78.5 degrees Celsius. The block is then ejected from the mold and cut into different sizes according to customer needs. For pellet production, instead of using a rectangular mold, carbon dioxide snow is fed into an extruder with holes of different diameters. A mechanical piston pushes the snow through the holes with great force, forming solid dry ice cylinders. Depending on the hole diameter, large 16 mm pellets can be produced for refrigeration and transport. The plant here also manufactures 3 mm pellets used for cryogenic cleaning. Dry ice still maintains a temperature of minus 78.5 degrees Celsius and must be kept in a controlled environment to prevent premature sublimation. The 16 mm pellets are poured into insulated containers, while dry ice blocks produced by another chamber weigh approximately from the range of 250 grams to 2 kilograms. Once production is complete, the dry ice is transported via conveyor belt to the packaging phase. At this point, various laboratory tests are conducted to measure the product weight, size and odor. The density and compactness of the dry ice are checked to prevent fragmentation. The size of the blocks is measured to meet sales standards. The end of the purity of the dry ice is verified to ensure it contains no impurities. After these tests, the dry ice is ready for storage and distribution. One challenge with dry ice is that it is very difficult to transport. It continuously transitions from solid to gas, gradually disappearing. This is why large thermal boxes made of polystyrene functioning like coolers are used. The goal is to maintain dry ice temperature and minimize its conversion to carbon dioxide gas. Storage is key to minimize dry ice sublimation, which occurs at the rate of approximately 5 to 10% per day, depending on the environment conditions. Before placing dry ice into storage containers, these are thoroughly cleaned thermal containers designed with insulating materials to reduce heat transfers and slow sublimation. The finished product is placed in the container to ensure preservation before being distributed to customers worldwide. Although dry ice at minus 78.5 degrees Celsius, it does not require electric refrigeration as it stays solid as its own. Dry ice is distributed to various industries including the food industry for preserving frozen products, hospitals for storing vaccines, biological samples and organs, and companies that use dry ice pellets for industrial cleaning without chemical residues. It is used in special effects to create fog in concerts, theaters and film productions.
As we have seen, dry ice is not just a cleaning medium, it is a precision engineered material. From liquefaction and pelletizing to insulated storage and time sensitive delivery, every step matters to maintain its quality and performance. Poorly stored or delayed dry ice can lose efficiency, costing your time and money during critical cleaning tasks. That's why choosing a reliable supplier like IceJet Dry Ice Manufacturing makes all the difference. At Surface Warriors, we ensure you not only get the best equipment and accessories but also the knowledge to use them right. Don't forget to subscribe, like and share this video. In our next episode, we will explore how to select the right nozzle and blast parameters based on your cleaning task. From delicate electronics to turbine blades. Thanks for watching Surface Warriors, where every surface matters. See you next time. Alvida. Thank you very much.